Every choice you've ever made, every single one, was yours. You chose to open this. You chose to keep reading. The deliberation that happens in your head before you decide something, that feeling of weighing options, of possibilities, of arriving at a conclusion, that is you. That is your mind at work. That is the most undeniable thing in existence. You are the author of your own thoughts. That's not a belief. That's the baseline. That's what it means to be conscious. That's what it means to exist. And every part of that is wrong. In 1814, a French mathematician named Pierre-Simon Laplace wrote a single paragraph, 4 sentences, tucked into a preface, that has never been answered, not once, not in 200 years. He described an intelligence that knows the position and momentum of every particle in the universe at a single instant, every electron in your neurons, every photon between your retina and this screen, every atom in the air you're breathing right now. He called it une intelligence, a vast intellect. We call it Laplace's demon. And his claim was this, that intelligence would see your next thought the way you see last Tuesday, completely, calmly, without surprise. Because it was always going to be that thought from the beginning, which means the specific thought you are having in this exact moment, not a general human thought, yours right now, was not formed in your mind. It was calculated at the Big Bang, 13.8 billion years ago, before this planet existed, before life existed, before you existed. Your next thought is already written. You're just arriving at it. I want to take you through 3 pieces of physics, Laplace's demon in full, what it actually says, and why it's never been refuted. Heisenberg's uncertainty principle, the one discovery that seemed to destroy the demon, and the reason it doesn't save you. And the block universe, what Einstein's relativity actually says about time, and why it means your next thought doesn't just feel inevitable. It already exists as a physical location. I don't have the final answer to what this means for you, but I have the physics, and the physics is more disturbing than the answer would have been, which brings us back to what we thought we knew, the self. The choosing self. It's the most obvious thing in existence, and it barely needs stating, which is exactly why it's so rarely questioned. You deliberate. You feel the genuine pull of 2 possibilities. Coffee or tea, say yes or say nothing, stay or leave, and something happens inside you that we call deciding. And whatever that process is, it ends with a choice. Your choice. One that came from inside you and nowhere else. The deliberation itself is the evidence. If the outcome were already fixed, the deliberation wouldn't exist. You feel yourself deciding because you are deciding. The feeling is the process. That's not philosophy. That's just introspection. And it works. That's the thing. It has always worked. You have navigated every significant moment of your life, every relationship, every risk, every word you chose to say or swallow, using the assumption that you are doing the navigating, not the universe, you. And not only does it work, it's the most reliable thing you know, more reliable than your senses, more certain than memory. The last thought you had before this one, you thought it, didn't you? And honestly, that's a complete picture. It is satisfying. It makes sense. There's just one problem. I'm going to show you 3 things. First, Laplace's demon, the paragraph written in 1814 that turned the entire universe into a solved equation. I'm going to show you exactly what it says and why, after 2 centuries of trying, nobody has answered it. Second, Heisenberg's uncertainty principle, the discovery that seemed to murder the demon in its sleep. And then I'm going to show you what happens when you actually read the fine print, because what Heisenberg saved is not what you think he saved. Third, the block universe, what Einstein's special relativity requires to be true about time, and why, if it's right, your next thought doesn't just have a cause, it has an address, a 4-dimensional space-time address that already exists. By the time we're done, you won't be able to make a single decision without feeling the equations underneath it. Let me start with the first one. And I'm going to go slowly, because this changes everything. In 1814, Pierre-Simon Laplace published a small book, a philosophical essay on probability. He had already spent 26 years writing Mécanique Céleste, 5 volumes proving mathematically that the entire solar system was stable, that Newton's equations could account for every orbit, every wobble, every deviation of every planet and moon. By 1814, he had proven that the solar system was, in essence, a machine, complicated, beautiful, but a machine. And in the preface of this essay, not in a formal paper, not in a treatise, just in the preface, he asked, what is the limit of this machine? How far does the calculation actually reach? His answer was 4 sentences. He described a being, a vast intelligence, Who knows, at a single instant, the position and momentum of every particle in the universe, every electron in your neurons right now, every photon that has ever left a star, every molecule of carbon that will one day be part of a person not yet born. For that intelligence, Laplace wrote, nothing would be uncertain. It would use Newton's laws, the equations of motion, to calculate every future state of every particle from that single moment of perfect knowledge. It would see your next thought the way you see last Tuesday. It would see your death the way you see this morning. It would see the last moment of the universe the way you see your childhood home. The future, for this intelligence, Laplace wrote, would be present to its eyes. That is the demon, not a metaphor, a logical consequence of the physics of 1814. This is what I told you about in the first 60 seconds. The paragraph written before the Earth cooled, and we still haven't answered it. Think of it like this. You're watching a game of billiards. 12 balls on the table. You know the starting position of every ball, the exact speed and direction of the cue ball, the friction of the felt, the weight of every ball, the elasticity of every cushion. You can calculate exactly where every ball ends up. That's not a trick. That's Newton. It's deterministic. Every effect has a cause. Every position at time t is calculable from position at time 0. Now, make the billiard table the size of the universe. Make the balls every particle that exists, every electron, every quark, every neutrino streaming through your skull right now at close to the speed of light. Keep the same physics, the same equations. The conclusion is the same. Your next thought is a ball on that table. The angles were set, not by anyone, by physics, by the equations that govern what matter does when it interacts with other matter. The equations didn't ask for your permission. They were always going to produce the next thought you have. The question of authorship is a question about billiard balls. But ask yourself this. If Laplace is right, if your next thought was calculable from the positions of particles before you were born, then what exactly is doing the thinking? When you feel yourself deciding something, what is the you that's doing the feeling? Is it the particles? The particles follow equations. They don't deliberate. They interact, attract, repel, vibrate, fire, but they don't sit there and weigh their options. So if the particles don't deliberate and the equations don't deliberate, where does the deliberation come from? And more pressingly, whose is it? Here is what has to be true if you are genuinely the author of your thoughts. Laplace has to be wrong. Not sort of wrong, catastrophically, fundamentally wrong, because a universe in which thoughts are calculable from particle positions is a universe in which the self, as an author, doesn't exist. The self might still exist in the way a shadow exists, but it doesn't cause anything. It's downstream of the particles. It's the result, not the cause. And here's the part that's hard to dismiss. Newton's laws were not guesses. They were confirmed by centuries of measurement to a precision that defies intuition. The position of Neptune was predicted by the equations before anyone had seen Neptune. The trajectory of every satellite we have ever launched was calculated using Newton's laws. The laws work. At every scale we can test, relentlessly. If those laws scale to the particle level, and there is no evidence they don't, then Laplace is right, and the self is furniture. But that's only the first layer, because 113 years after Laplace published that paragraph, in 1927, in a paper by a 25-year-old German physicist named Werner Heisenberg, the demon appeared to die. For about 40 years, physicists actually relaxed. Then they read more carefully, and that's when it becomes genuinely disturbing. And that's just the first one. The second one was supposed to be the rescue. It isn't. But here's where this gets strange, because the thing that was supposed to save us from Laplace, the discovery everyone points to, actually makes the problem worse. Stay with me. In 1927, Werner Heisenberg published a paper that seemed to end the conversation. Here is what the uncertainty principle actually says. And I want to be precise about this because it is almost universally misquoted. You cannot simultaneously know the exact position and the exact momentum of a particle. The more precisely you pin down where a particle is, the less precisely you can know how fast it's moving and in what direction, and vice versa. This is not a limitation of instruments. It is not because our microscopes are too crude. It is not a gap that better technology will close. It is a feature of reality itself. The universe at the quantum level does not have precise simultaneous position and momentum, not because we can't see it, because it doesn't exist. The measurement is this. The uncertainty in position multiplied by the uncertainty in momentum is always at least h over 2, that's h bar, divided by 2, approximately 1.055 times 10 to the negative 34 joule seconds. You cannot reduce both uncertainties below that bound. simultaneously, ever. And Laplace's demon needs exact position and exact momentum for every particle. Reality says you cannot have both. The demon cannot exist. Problem solved. Free will saved. Except think of it like this. Imagine you're trying to photograph a hummingbird in flight. Not with a bad camera, with any camera governed by one absolute rule. Your shutter can be infinitely slow or infinitely fast, but never both at once. Infinitely slow. You see a motion blur. The path of the wings, but no single position. Infinitely fast, you freeze the wing. But you lose all information about direction and speed. You can never get a sharp image of a moving wing. Not because of the camera, because a sharp image of a moving wing is a combination of information the universe doesn't allow. That's Heisenberg, not a measurement problem, a reality problem. So the demon can't know both position and momentum. The demon can't calculate the future. Physics is fuzzy at the bottom. Randomness is real. You are free, or are you? Here's the question nobody asks when they hear this. Quantum mechanics gives us randomness, genuine, irreducible randomness. Good, let's say the demon is truly dead. Now, where does that randomness live? It lives in the quantum events firing in your neurons, quantum fluctuations that, under some models, influence which neurons fire and which don't, which means your thoughts are partially, possibly significantly, driven by quantum randomness. So your next thought was not calculated by Laplace's demon. It was determined by a dice roll in your neurons. And the question I want you to sit with is that better? Think very carefully about what quantum randomness gives you free will actually means. A quantum event fires in a neuron, unpredictably, irreducibly, randomly. It influences the thought that forms. You did not choose the quantum event. The quantum event is random. By definition, nobody chose it. Not you, not a prior cause, not anything. It just happened. The thought that emerged from that random quantum event, is it yours? You are not the author of a random event. You are the location of a random event. The thought landed in you the way lightning lands in a field. The field didn't choose the lightning. Replacing determinism with randomness doesn't give you freedom. It replaces one kind of non-authorship with another. Laplace's demon stole your pen. Quantum randomness burned the paper. Either way, you didn't write the sentence. This is not my conclusion. This is Sean Carroll, one of the most serious theoretical physicists working today, saying it clearly in print. Randomness is not the same as free will. Randomness is just noise. But here's what even this doesn't address, because there is a third piece of physics that doesn't ask about particles at all. It doesn't ask about what causes what. It asks something more basic. It asks, what is time? And the answer, Einstein's own equations force upon us, is the strangest thing in this entire video. It's about your next thought, not its cause, its existence. I'd stop here if that were the whole story. It's not. Wait, before you process the randomness argument, there's a second thing happening here that nobody mentions. And it doesn't care whether the universe is deterministic or random, because it's about something deeper than cause. It's about the nature of time itself. On September 21st, 1908, Hermann Minkowski, a German mathematician, Einstein's former professor, stood before the 80th Assembly of German Natural Scientists and Physicians in Cologne. He opened with this sentence: "Henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." This was not philosophy. This was the mathematical consequence of what Einstein had published 3 years earlier, special relativity. Einstein had shown that the speed of light is the same for all observers, regardless of their motion, and the mathematics that makes that work requires something astonishing. Time is not a universal backdrop against which events occur. Time is a dimension, a fourth dimension, like the 3 dimensions of space: length, width, depth. But time, space-time, one unified 4-dimensional structure. And here is the word that should stop you: structure. Structures don't become, they are. The Eiffel Tower doesn't become at a certain time of day. It exists in 3-dimensional space. It's there, completely, simultaneously. If time is a dimension, if space-time is a structure, then every event in time is there, completely, simultaneously, past, present, and future, as equally real as left, right, and forward. Your next thought exists, right now, at its space-time address, as a physical location. Think of it like this. You're watching a film, an old-fashioned film reel. Somewhere in the cinema, the reel sits in its canister. Every frame of the film exists simultaneously on that reel. The first frame, the last frame, every frame in between. They are all there, equally real, equally physical objects. When the film plays, you experience it as a sequence. Beginning, middle, end. Things happen. The story unfolds. The future of the character is unknown to you, but it's not unknown on the reel. Every moment of the character's story already exists as a physical object on the reel. In the block universe, time works like the reel, not like the projection. Every moment of your life, the moment you were born, the moment you will die, and every thought you will have between them, exists simultaneously in the four-dimensional structure of space-time. Not as a possibility, not as a potential, as a location. You are not watching a film being written. You are a film that is already complete, and you are the point of light moving through it. But ask yourself this question very carefully. If every moment of your future already exists as a physical fact, if your next thought has a space-time address the way your home has a street address, then what is the you in this picture? You feel like you're moving toward the future, approaching it, choosing it. But if the future already exists, you're not approaching a place that doesn't yet exist. You're approaching a place that has always existed. Is that moving or is it arriving? Is the you reading this a consciousness moving through time, or is consciousness the experience of a pattern, a very complex, very specific pattern that exists at each space-time address, and the feeling of continuity is the way those patterns register their connection to each other? Are you in time, or are you made of time? Here is what has to be true if the block universe is correct. The future is not open. It feels open. It feels as if right now you could think any one of 100 different thoughts next. You feel the branching possibilities. You feel the openness. But if space-time is a four-dimensional structure, if your next thought exists at a specific set of coordinates in that structure, then the openness is not in reality. It is in you, specifically in the present moment slice of consciousness that is moving through reality and does not have access to future coordinates. The universe is not being written as you live it. You are reading a text that was typeset before the beginning. Your sense that the future is open is not wrong exactly. It is the correct experience of a consciousness that can only access one moment at a time. But it is not a feature of reality. It is a feature of how reality is experienced from the inside. The physicist Julian Barber spent 40 years on this. His 1999 book, The End of Time, argues that time itself does not flow, that the appearance of flow is a property of the patterns of information in the universe, not of the universe itself, that every moment exists, that none of them passes. He is not universally agreed with, but no one has proven him wrong. And now put all three of these together. Classical determinism, your thoughts have prior causes, calculable from particle positions. Quantum randomness, your thoughts have prior quantum causes, which stripped authorship from you without giving it to anyone else. Block universe, your thoughts don't just have prior causes, they have prior existence. They exist before you think them. You are not authoring a story, you are a feature of a story that is already written, that has always been written. And that's when you realize Laplace's demon was never a being. It was always just a description of the universe describing itself. So the wrong answer is destroyed 3 times over. But we still haven't answered the real question, which is, what is actually happening? Because the true answer is stranger than the wrong one. I need to stop here, because the number I'm about to walk you through, the actual consequence of these 3 pieces of physics stacked together, changes the shape of everything before it. So if the self doesn't author thoughts the way we feel it does, well, what is actually happening? Let me build this from the ground up, step by step. I'm not going to skip anything. The universe, at the level of classical mechanics, is a system of differential equations. Given exact initial conditions, every future state is fully determined by the present state. This isn't a claim, it's what the equations are. Newton, Lagrange, Hamilton, 300 years of verification, every satellite launched, every comet predicted, every GPS system running on your phone. All of it is deterministic classical mechanics working. In quantum mechanics, the situation is more subtle, but not, as it turns out, more comforting. The wave function, the complete quantum description of any system, evolves in time according to the Schrödinger equation, completely, deterministically, smoothly. The randomness only appears at the moment of measurement, when the wave function is said to collapse into a single outcome. And here's the thing, why measurement causes collapse is one of the deepest unsolved problems in physics. It is called the measurement problem. We do not know why it happens. Which means right now, in this moment, there are serious physicists, not fringe scientists, not philosophers with physics envy, but Nobel-level working physicists who believe the wave function never collapses at all. that every quantum possibility plays out in a branching universe simultaneously, that you, the you reading this sentence, branched off from every other version of you the last time a quantum event occurred in your brain, and that every one of those versions is having an experience that feels exactly like free will feels to you right now, every single one. Now add the block universe. Space-time is four-dimensional. Past, present, and future are all equally real locations within that structure. The physicist Brian Greene describes it as a frozen river. The river doesn't flow. Every position along it, every moment in time exists simultaneously. We move through it, or rather, our experience moves through it. If space-time is the frozen river, then the word future is a direction in the structure like north, not a time that hasn't happened yet. The future isn't approaching. It's already there. The distinction between what has happened and what will happen is a distinction made by a consciousness at a particular location in the river, not a distinction in the river itself. Not yet is a property of your position, not of reality, which means your next thought, the one you haven't had yet, has space-time coordinates. It exists at a specific address in the four-dimensional structure of reality, and the feeling you have right now that you're about to choose what to think next is not the feeling of creation. It is the feeling of arrival. You are not walking toward a thought. You are arriving at a thought that was already there, like a traveler approaching a city that has always existed, convinced they are building it as they walk. Combine classical determinism with the block universe, and here is the picture you get. The universe is not a story being written. It is a structure that already is. Every particle, every interaction, every causal chain, it is all there in the four-dimensional shape of space-time, from the first moment to the last. Which means you are not the author of a story. You are a character in a story so precisely written that the character has an inner life, a rich, continuous, urgent inner life that feels like authorship, feels like choosing, feels like creating. The feeling is real. The authorship is the question. It is like discovering that you are not the candle flame lighting the dark. You are the process, combustion, repeating. Each instant a fresh event generating the appearance of continuity. And you, the thing reading this, are what the process feels like from inside. And I know this sounds like theory, like something assembled from equations in a quiet room. It is not. There is one person who built this framework with his hands and described it, and then spent the rest of his life sitting with what he'd described, and then they found something nobody was looking for, not about the physics, about the physicist. Pierre-Simon Laplace was born in 1749, Normandy, France, the son of a farmer. He was brilliant in the way that makes people around you uncomfortable, the way where you solve the problem while they're still reading the question. By his 30s, he was the most important mathematician in France. By his 40s, he was working directly with Napoleon. By his 50s, he had written the Mécanique Céleste, 5 volumes that completed what Newton had started. The solar system, fully calculated, fully deterministic, a machine of extraordinary precision. What consumed him was this question: where does the calculation stop? His answer, the demon, the vast intellect, the intelligence that sees future and past as present, was not the conclusion of a grand philosophical treatise. He buried it in a preface, 4 sentences, written as if the implication were obvious, as if the only reason to state it was completeness. For Laplace, the demon wasn't a puzzle, it was a consequence. The universe is deterministic, therefore everything in it, thought, feeling, choice, love, grief, memory, is calculable. He wrote it. He moved on. He had more mathematics to do. Napoleon Bonaparte, who had personally appointed Laplace to the Senate and later made him a Count of the Empire, is said to have confronted him about the Mécanique Céleste. Monsieur Laplace, I have been told you have written this great work on the system of the universe without once mentioning its author. And Laplace replied, in a sentence that has been quoted in every serious treatment of determinism since, Je n'avais pas besoin de cette hypothèse-là. I had no need of that hypothesis. The exchange may be apocryphal. Historians argue about it. The precise words may be embellished, but the position is documented. Laplace confirmed it in his writing. His universe runs without a director. It runs on equations, and the equations are sufficient, and God is an unnecessary addition to a model that already works. Here is what I cannot stop thinking about. Laplace had just removed God from the system. The great intelligence that sustains and knows all things. Unnecessary. The equations are enough, but the same logic applies to Laplace. If the universe runs on equations, if every particle's position is calculable from every prior position, then the thoughts Laplace had while writing Mécanique Céleste were calculable from particle positions before he was born. The paragraph about the demon was not composed by Laplace. It was the inevitable output of a deterministic physical system that happened to be located in 1814 at a writing desk in Paris. Laplace built a universe in which Laplace does not exist as a creator, and he never addressed it. He moved on to the next section of the book. He died in 1827. His reported last words, "Ce que nous connaissons est peu de choses, ce que nous ignorons est immense." What we know is a small thing. What we do not know is immense. He had spent his life proving the universe was fully calculable, the model of perfect knowledge. And at the end he said, "We know almost nothing." Either he was being modest, or the demon, in his final hour, had arrived at the edge of what equations can actually tell you about the self that writes them, and found it silent. Laplace's 4 sentences launched 2 centuries of serious physics, every treatment of determinism, free will, the arrow of time, quantum indeterminacy, the hard problem of consciousness. They start in that preface, not because Laplace was the first to think about determinism. The Stoics thought about it. The Persians thought about it. But Laplace was the first to write it as a physical calculation rather than a theological position. He moved it out of philosophy into physics, where it has been impossible to answer ever since, which means the next time you feel the experience of choosing, the specific warm sensation of a decision landing in your mind, Laplace's equations are already in that moment. The space-time coordinates of that moment already exist. The particle trajectory that generated it was already set. The experience of choosing is real. Physics doesn't deny that you feel it. It just hasn't explained what it is. And Laplace did not notice. That was missing. But here's what even Laplace couldn't answer. What nobody has answered. What keeps the most serious physicists alive today genuinely, honestly uncertain. Remember the claim in the first 2 minutes that the thought you are having was calculable from the Big Bang? Here is what the most serious physicists in the world actually disagree about when they sit with that claim. The question is this: does quantum indeterminacy, the genuine foundational randomness of quantum events, give you back something that determinism took away? Is there, inside the randomness, a place for the self to actually do something? Serious people disagree, credentialed, brilliant, careful people, not because they haven't read the physics, because the physics genuinely supports both answers and no measurement has separated them. Roger Penrose, mathematician, physicist, the man who proved alongside Stephen Hawking that black hole singularities are an unavoidable consequence of general relativity, has spent decades arguing this. He and the anesthesiologist Stuart Hameroff developed what is called orchestrated objective reduction, OR. The argument, quantum processes in the microtubules inside neurons, structures so small they operate at the quantum boundary, are the actual mechanism of conscious experience. And quantum collapse events in those structures are genuinely unpredictable, not calculable, not written in advance, real novelty. If Penrose and Hameroff are right, consciousness is not downstream of physics. It is where quantum mechanics and space-time geometry actually meet, and the self is real, not illusory, not furniture. This is not fringe science. Penrose is one of the most rigorous mathematical minds of the 20th century. The theory may ultimately be wrong. It has critics who believe the brain is too warm and wet for quantum coherence to survive in neurons, but it is not a desperate grab at mystery. It is a serious attempt to locate the self in the physics. Sean Carroll, Daniel Dennett, Galen Strawson, 3 thinkers who spend serious time on this question, who disagree with each other about almost everything else, who converge on this. Randomness is not authorship. If a quantum event fires randomly in your neuron and produces a thought, you did not choose the quantum event. The quantum event is random, unpredictable, without prior cause, not calculable, and you were not consulted. The thought landed in you. You didn't throw it. Replacing determinism with randomness doesn't give you the pen back. It just means no one is holding the pen. Your next thought is either the output of an equation or the output of a cosmic dice roll. Neither of those is you making a decision. You are either a calculator or a lottery ticket. Neither one is free will. We do not know. That is not a diplomatic answer. That is the actual state of the physics. The people who tell you quantum mechanics saves free will are telling you what they hope. The people who tell you determinism proves the self is an illusion are telling you what the equations suggest, not what they prove. Between the particle and the person, between the quantum event firing and the experience of deciding, there is a gap. The physics goes quiet in that gap. The equations stop, and something happens that the equations don't describe. David Chalmers named that gap in 1995. He called it the hard problem of consciousness. It is the hardest problem in all of science. And it has not been solved, not even approximately. This gap is not a failure of science. Science has been at its most productive when it is at its most honest about what it doesn't know. The hard problem of consciousness is not waiting in a laboratory somewhere for a smarter measurement. It is sitting inside you, right now. As you process these words, the gap is active, the equations are running, and whatever happens between the running equations and the experience of understanding, that is the problem. That is the edge of the map. The edge is always the most interesting part, and this is not an abstract uncertainty. It is not sitting somewhere waiting to be resolved. It is sitting inside you right now. It is personal. I need to stop here, because what I'm about to say is not a philosophical implication. It is about a specific moment you have already lived. A real one. Hold on. So here is what this means for you. Not for humanity, not for consciousness as a concept. For you, tonight, in the specific body you are sitting in. Every thought you have identified as yours, every idea you were proud of, every decision you considered brave, every moment of clarity you remember as I figured that out, either emerged from a deterministic particle trajectory that was set before the Earth formed, or from a quantum event that happened in your neurons without asking you first, or from a space-time address that already existed before you arrived at it. In every case, the question of who authored the thought is open, and not just today. In 4 billion years, the sun expands. This solar system ends. Every memory of every thought you ever had, dispersed. The atoms that carried those thoughts will be part of the expanding stellar envelope of a dying star. Physics doesn't mourn that. Physics describes it. From outside, the difference between a universe that contains you and a universe that doesn't is a particular set of particle configurations lasting roughly 80 years. Physics sees no difference in the weight of that. Think of the last truly spontaneous decision you made. Not a big one, something small. The route you took for no apparent reason. The word you chose over another one in a conversation without knowing why. The thought that arrived fully formed, from nowhere you felt, that turned out to be true. Hold that moment. You probably called it intuition, or instinct, or just you. Now here is what the physics is asking about that exact moment. Was there a particle trajectory, calculable from the Big Bang that generated it? Was it waiting at a space-time address you were always going to reach? Was there a quantum event that fired, not chosen by you, not caused by you, that produced the feeling of sudden clarity? And if any of those are true, if the spontaneity was an experience rather than a genuine origination, does that change what the moment was? Does the moment survive the physics? I have asked myself this about specific moments in my own life, and I cannot answer it, and I cannot stop. You are not a person who has thoughts. You are a physical process. 86 billion neurons, approximately 100 trillion synaptic connections, operating at electrochemical speeds, that generates the experience of having thoughts. Whether the generator is the author, or whether the author is something else entirely that the generator produces, or whether the very concept of author dissolves at the particle level, that is the question. That question is not out there. It is you, right now, in the present tense, which means the only honest place this can end is the only honest place anything real ends. And then they found something nobody expected in the equations themselves. Something that Laplace could not have seen in 1814, but that modern physics cannot ignore, and it changes everything about how dark this is. Remember the paragraph from 1814, the 4 sentences that started all of this? Here is what 2 centuries of serious physics has found when it has stared at those 4 sentences. So next time you feel yourself mid-thought, in the moment between a thought arriving and you claiming it as yours, remember what the physics says about that moment. The atoms that fired were following laws that have been verified by every GPS satellite, every solar prediction, every particle accelerator run in the last century. The wave function was evolving exactly as the Schrödinger equation required. The space-time coordinates of that moment existed before the Earth formed. And remember, Not one physicist, not one neuroscientist, not Laplace himself, nobody has fully explained the gap between the particle trajectory and the experience of the thought. Nobody has closed the distance between the firing neuron and the feeling of understanding, between the quantum event and the sense of, I just realized something. That gap is still open. It has been open for 200 years. It will not close quietly. And to me, that is not a failure. That is not a gap in the map that needs filling before we can move on. That is something better than an answer. The universe built from quarks and forces and 4 dimensions of curved space-time, something that can sit with the equations that describe it and feel disturbed, a calculation that can wonder about the calculator, a determined system that can ask whether it is free, a process that can, in this specific moment, watch itself process. That is not a flaw in the determinism. That might be the most extraordinary fact in physics. Think about the last truly spontaneous thought you had, the one that felt like it came from nowhere, purely, unmistakably yours. Now sit with this. If Laplace's demon is right, if that thought was written into the trajectory of the universe before the Earth existed, does it still feel like yours? Does the ownership survive the physics? Tell me in the comments. I'm asking because I have asked myself, and I genuinely don't have the answer, and I want to know if you do. If this disturbed you, and I think it should, the next video is about the physics of identity, not free will, something more personal. The question of whether the person who woke up in your body this morning is the same person who went to sleep last night. Mathematically, physically, and what the physics finds when it looks at that question is more unsettling than anything in this video. I'll leave the link